Let's talk about one of the burning questions in physical chemistry. Why do reactions have an activation energy barrier? If reactions are meant to happen, why don't they occur instantly the moment particles collide? The answer lies in the activation energy barrier. For a chemical reaction to take place, existing bonds must first be broken or weakened, and new bonds must be formed. That process, bond breaking and bond making, is what we call a chemical reaction. Now, bond breaking always requires energy. That's because bonded particles exist in a lower energy, more stable state. The moment a bond starts to break, the particles become less stable and higher in energy. This extra energy must be supplied from outside the system. The high energy, unstable state where bonds are breaking and new bonds are beginning to form is called the transition state. When particles collide, they don't just need the correct orientation, they also need enough energy to reach this transition state. Only collisions with sufficient energy can overcome the activation energy barrier. If the energy is too low, the particles simply collide and separate, and no reaction occurs. This explains why some reactions are slow, even if they are exothermic. Although energy is released overall, an initial input of energy is still required to start the reaction. Catalysts work by lowering the activation energy barrier. They provide an alternative reaction pathway that requires less energy, allowing more particles to reach the transition state at the same temperature. So remember, activation energy exists because bond breaking costs energy, and only particles with enough energy can react. Subscribe to our newsletter for more free content. The link is in the bio. Yours, Atom Academy.